Hello everyone, welcome to the solution of LeetCode problem 2508 named Add Edges to make degrees of all node even. In this problem, we are given an undirected graph consisting of n nodes numbered from 1 to n. Now, you are given the integer n and a two-dimensional array where each array element contains two integers a and b. Now, this indicates that there is an undirected edge between the node a and b, and the graph can be disconnected. Here, you can add at most two additional edges, possibly none, to this graph so that there are no repeated edges with or no self loops. Now we have to return true if it is possible to make the degree of each node in the graph even, otherwise we have to return false. Now, the degree of a node is the number of edges connected to it. So here let's consider the first example. Node 3 and 4 are connected, 4 and 1 are connected, 1 and 2 and 3 and 2 is connected, 4 and 2 is connected, 5 and 2 is connected. Now here we can see that this node 4 has degree equal to 3 because it has 3 other node connected. And this node 5 has degree 1. So both of the node 4 and 5 has the odd degree. So if we establish a connection between the 4 and 5, the degree of 4 will become 4 and the degree of 5 will become 2. Eventually, all of the nodes in this graph have the even degree. So here we have to return true. Otherwise, if we cannot make the degree of every node even, we have to return false. I hope you understood the problem statement. Now let's move on to the algorithm. Now here, to understand the algorithm, we have taken the same example. Here we are given this graph and 4 has odd number of degree and 5 has odd number of degree. So if we make a connection between 4 and 5, all of them will have the even number of degree. So as this is a graph problem, now let's make the adjacency list by using this graph, and we will determine which node has the odd degree. So here, for this edge, we will add 4 in the adjacency list of 3, and we will add 3 in the adjacency list of 4. Now, for this, we will add 4 in the adjacency list of 1, and we will add 1 in the adjacency list of 4. For this, we will add 2 here, and in the 2, we will add 1 here. For this, in the 5, we will add 2, and in the 2, we will add 5. For this, in the 3, we will add 2, and in the 2, we will add 3. And for this 4 and 2, in the 4, we will add 2, and in the 2, we will add 4. Now, if we understand or determine which node had the odd degree, we will find 2 of the node has the odd degree. The node 4, which has a degree equal to 3, and the node 5, which has a degree equal to 2. Now, we have found so far 2 of the node 4 and 5, which has the odd number of degree. So we will check whether there is a direct connection between these two 4 and 5 or not. No, there are no direct connection. So we will simply add the node 4 and 5. So if we add the node 4 and 5, the 5 will be added in the adjacency list of 4, and the 4 will be added in the adjacency list of 5. Eventually, all of the node will have the even number of degree. So here, There can be two cases. After building the adjacency list, it can be possible that no of the node has the odd number of degree. That means initially all of the node has the even number of degree. So in this case, we have to return true. Otherwise, we have to store the all of the node which have the odd number of degree. And here, if the number of node has the odd number of degree is 2, we have to run a loop from 1 to n, and for each any of the I, and any of the I, we find that I is not connected with 4 and I is not connected with 5. In this case, we can establish a connection between 4 and 5. So eventually we will make all of the node which have the even number of degree. Now, it can be possible that the node which has the odd number of degree is equal to 4. Suppose, let's understand this case. There are 4 nodes which has the odd number of degree. Now here, these 2 nodes will have the even number of degree, but these 4 nodes has the odd number of degree. Or let's make it more intuitive. Let's make a node here. Now it will be more clear. We can say that these red nodes has the odd number of degree. Now, it can be possible that the number of node which has the odd number of degree is equal to 4. So here, if this node is not connected with this node and this node is not connected with this node, we will make the connection and eventually make all of the node which have the even number of degree. As we can build or establish at most 2 of the connection, this is the scenarios. Now, this is the first case. Again, it is possible that this node is not connected with this node and this node is not connected with this node. If it is not, then we can establish this connection as well. Now again, it is possible that this 2 node is not connected and this 2 node is not connected. So if it is, we can simply make the connection and make all of the degree of the nodes even. So this is the algorithm. At first, we have to make adjacency list and we have to determine how many numbers of node which have the odd degree. If the number of node which have the odd degree is 0, 2 or 4, in this case, we can return true after checking some of the conditions. Otherwise, we can return false, or it is not possible to make the graph even degree for all of the nodes. So here, if if the number of node which has the odd degree is 0, we have to simply return true. Otherwise, if the node which has the odd degree is equal to 2, in this case, we have to check does any of the I from 0 to n does not connected with this both of the node or not. If they are not connected, we can simply establish the connection and make all of the node degree eventually even. And if the number of nodes which have the odd degree is 4, we have to check 3 possible connections. Suppose the first possible connection is this white line, the second possible connection is this red line, and the third possible connection is this green line. And if any of the connection is true, that means initially any of the connection does not exist, we have to simply return true because after establishing two of the connection, we can eventually make all of the degree of all nodes even. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function name is possible, which has integer n and vector of edges. Now, we are declaring a vector of set and vector of integer name dot. Now, let's build the adjacency list here. And we have to check which node has the odd degree. And if any node had the odd degree, we have to simply insert it into an odd vector. And if the size of the odd is equal to 2, and for any of the node from 1 to n, if node I is not connected with odd 0, that means the first odd element, and node I is not connected with the second odd element, we can make the connection and return true. Here we can make one edges. Now here it can be possible that the size of the odd is equal to 4 if in the odd vector the first element is not connected with the second element and second element is not connected to the third element, or the first element is not connected to the third element and the second element is not connected to the fourth element, or the first element is not connected to the fourth element, or the second element is not connected to the third element. If any of these conditions become true, then we can establish two of the connections and make the degree of all of the node in this graph true. So we have to return true here. Otherwise, if the size of the odd is equal to 0, we have to return true. Otherwise, we have to simply return false. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.